Good morning, everyone, and welcome to RTC at Scale 2023. I'm super excited to join you all today and talk about the advancements we have made in real-time communications at Meta. When we met last year, we were just getting out of the pandemic, and none of us knew the actual shape RTC was going to take in a post-pandemic world. Now that we have a year of post-pandemic data, it is clear that advancements in RTC are here to stay. Globally, there are more than 300 million audio and video calls on Messenger every day, and once we add Instagram and WhatsApp to the mix, that number is significantly higher. Our goal at Meta has always been to bring people together when they are apart, and our investments in real-time communications platform have played an important role in this journey. So how do we bring people together? Who do we make real-time communications more delightful for? Last year, we discussed the vision of making audio and video calls more fulfilling by allowing people to do things together during a call. Throughout 2022, we saw this vision come to life. Our investments in features such as Watch Together and group effects in the Messenger app saw adoptions by our users. We also made investments to enhance the screen sharing and whiteboarding experiences in our apps so people can collaborate and create when they are miles apart. We also found that our users want to express themselves during calls, just like they do in real life. To facilitate this, we made investments in expanded reactions, raise hands, and features like live polls, in-call timers, and fun, delightful AR effects to really bring virtual calls to life. And to complete this vision, we are also working on RTC Avatars, as Mark announced at Connect last fall, which would be yet another way for people to express themselves. Traditionally, RTC at Meta has been mobile first, with one-on-one and small group calls dominating the call volume. In 2022, we broke from this mold with 32-person video calls launching on WhatsApp, and 32p is just the start. We are super excited for the future. The technical investments that we have made will allow us to support really large calls in the future. We also invested in offerings beyond mobile and completely revamped the Messenger desktop apps for Mac and Windows. Messenger desktop app for Mac now natively supports M1 and M2 processors and is twice as fast. This app really brings our large calling experience to life with a grid that can dynamically size and paginate with 25 videos per page, so you can really see everyone on the call. Features such as Watch Together, polls, timers, screen sharing, and whiteboarding really come to life in this form factor. Lastly, we continue to invest in the metaverse to fulfill our vision of breaking out of the grid completely into an immersive 3D space. Put together, all these investments made 2022 the largest year by call volume for RTC at Meta. So how do we do this? What is the technology stack that powers it all, and how do we build it? Let's go into a technology overview. First and foremost, we are built on top of WebRTC and are committed to the WebRTC ecosystem. We have our own implementation of signaling protocol, media state machines, and a client-side library called RSys, which provides a clean SDK for client-side applications to integrate RTC features. This single tech stack, called Meta RTC, powers multiple applications in the company. Messenger, Instagram, Facebook, Workplace, and Metaverse applications all leverage this single unified stack for RTC. Now, there are several advantages of a unified stack. First and foremost, fixes and optimizations permeate to all applications that are built on top of the stack. Second, it leads to developer efficiencies. Product development engineers do not need to understand the nitty-gritty details of the RTC stack and have a clean API to work with. They don't worry about echo cancellation and codec optimizations, for examples. Third, it leads to operational efficiencies as well. Running a RTC backend system at meta scale is complex and requires optimizations at all layers of the stack, from networking to media to overall capacity management and scaling for high traffic events like the FIFA World Cup final or the New Year's Eve. Now, let's deep dive into RSys. RSys is our client-side library that originated in Messenger to provide a clean abstraction for Messenger product engineers. Over the years, we have rewritten and optimized this library to be small enough to run on Ray-Ban smart glasses, yet powerful enough to support large screen experiences for our desktop app. Written in C++, the library is also cross-platform and works across iOS, Android, macOS, and Windows. RSys supports extensibility using a plugin mechanism and has a state machine architecture that is well understood by our product engineers. The entire library is less than 10 megabytes in size installed on disk. Today, RSys powers all Meta RTC applications and Oculus devices except WhatsApp. Now, let's talk about some key technical investments over the last year. Continuing with RSys, we made several improvements and optimizations to enable RTC experiences on smartwatches, AR glasses, and apps like Facebook Lite that are very constrained on CPU, memory, and binary size. In addition, we enable value-added capabilities that go beyond vanilla calling, such as avatars and immersive experiences like co-watching and co-playing. This solid foundation will allow us to bootstrap rich experiences powering the metaverse across multitude of form factors: web, mobile, VR, and AR, and also interop between them. Next, let's talk about scaling to large calls. Fluctuating network conditions, network congestion, resource usage on devices are all known problems for calling. But the real challenge comes when trying to solve it at scale. Scaling to large calls not only means pushing more video and audio streams, leading to higher bandwidth usage, it also impacts client-side processing as these video streams must be decoded and rendered. Moreover, the user experience has to be smooth when paginating through videos on the client. On WhatsApp, every call is end-to-end encrypted, which means tricks like server-side rendering of video streams and server-side mixing of audio streams can't work. Meta can only route these audio and video streams through our infrastructure. Encoding, decoding, up and down sampling is all done by the clients. Moreover, a significant portion of our users are mobile only and have constrained networks, which makes this an even interesting and a challenging endeavor. We had to tweak our stack from client to edge in order to support large calls across our family of apps. For example, we introduced selective forwarding and dominant speaker optimizations on audio streams to only send down audio streams that will lead to the best call experience and avoid sending the rest to save bandwidth. We also invested in simulcasting, temporal layering, and bandwidth estimator optimizations to optimize video quality experience across a range of available user bandwidths. As a last resort, we relied on the client to selectively shut down the least important video streams so that the dominant speaker is always visible on the call. We also tweaked the app UX to better inform users of network limitations and actions they could take to improve their experience. Beyond scaling for large calls, we also invested heavily in improving the overall reliability of our service this year. Operating at meta scale, it is important to not only look at the percentage of users having a good experience with our service, but also reduce the percentage of users that are having a bad experience. If 10% of call sessions experience a glitch on a given day, that would amount to tens of millions of users having a bad experience that day. We fixed this by introducing a composite metric, aptly named %bad, which tracks bad user experience end-to-end. This single metric covers things like call connect failure, last-minute quality regressions, network drops, media flow issues, and app crashes, each weighted by the amount that they contribute to a bad user experience. By focusing on a single composite metric, we were able to measure and improve bad user experience over the last 6 months. We shipped fixes that addressed connect failures, network drops, media flow issues, and crashes. Collectively, this improved % bad metric by 7% globally and 19.6% in the US, making audio and video calls more reliable for our users that were suffering the most. Finally, let's talk about our clients. The single most important aspect of any RTC client is the call stage, and the hero feature of that stage is the grid of call participants. You want to see all of your friends in the call. This piece of UX is complex because it not only has to dynamically resize based on the aspect ratio and participants joining and leaving the call, it has to be highly performant and avoid GPU buffer copies that might come from stitching and bleeding video streams. To solve this problem, we created a single call grid implementation that is platform agnostic and can scale from mobile phones to large screen displays. We wrote this grid in C++ and optimized it for performance, natively integrating into our iOS, Android, macOS, and Windows apps. We also leveraged WebAssembly to avoid creating a custom JavaScript implementation for the web, leading to both performance and code reuse wins. So, what's our journey from here, and how do we build for the future? First and foremost, we are going to continue to invest in the Meta family of apps and ensure we have the best real-time communications experience on the planet. At the same time, we are looking at newer form factors to leverage our solid foundation and innovate. Metaverse brings interesting technical challenges with it. Imagine a virtual world in 3 dimensions in which you can not only see your friends, but also interact with them in real time, play virtual chess, see each other as holograms, bring in apps to collaborate in 3D space. We are working hard to bring this to life with our continued investments in Horizon Worlds. However, this is leading us to optimize everything from transport to rendering. We will need more efficient codecs, for example, as we will have to compress more data into the same data stream while ensuring there are no lags. We will have to invest in spatial audio and AI that can generate scenes on the client from metadata to avoid transferring copious amount of data between the clients. Lastly, we are also seeing use cases of RTC investments beyond just face-to-face calling. The Oculus desktop app, which allows users to create multiple virtual desktop extensions of their PC, is built on top of our screen sharing investments in RSys. We optimize this to a point where end-to-end P95 latency on Windows is less than 81 milliseconds, making the virtual desktop in Oculus virtually indistinguishable from physical monitors connected to a computer. Now, as the form factor of VR headsets improve, you can imagine just wearing smart glasses that can remotely stream your entire computer from the cloud, giving you a large virtual space to work on. I am super excited about this future. With that, I want to thank everyone for tuning in and joining us for RTC at Scale 2023. We have tons of exciting challenges ahead of us, and I am looking forward to building this future together with you all in the coming years. We have a great speaker lineup today, so tune in for the rest of the talks. Thank you, and looking forward to doing this again next year.